Welcome to Study Loop.
So we have an evacuated container. We have a given volume and we have a given mass. And then we have the root mean squared velocity of the gas molecules within that container. And then it's asking us what's the pressure inside the container. Um, this is a two-step problem. Let's first write our givens. 1.64 liters equals 0.00164 meters cubed. Unless you're going to be dealing with only liters and atmospheres, you're going to want to have to convert to SI units, because then you'll make all of your calculations much easier. And then you can use the ideal gas constant of 8.314, because 0.08206 is only used for if you're dealing with pressures in atmospheres and volumes in liters. So we're going to have to automatically convert all of our units to SI units. And then we have 0.226 grams of nitrogen gas, or 0.000226 kilograms of nitrogen gas. Then we have the root mean squared velocity of this nitrogen gas, 182 meters per second. Now, the root mean squared velocity is going to be equal to 3RT over the molar mass of nitrogen gas. And again, this is just the formula for root mean squared velocity. So we can say now that the temperature is going to be equal to mv, the root mean squared velocity, squared over 3r. And again, we're only finding the temperature because we want to find the pressure. So finding this, we can actually just plug in. So this would be the molar mass of 0.02814. This is simply the molar mass of nitrogen, and then 182 would be our 182 squared would be our temperature. And then this is going to be equal to 3 times 8.314. And we find that the temperature is going to be equal to 37.20 Kelvin. At this point, we can say, okay, let's find the number of moles. So if we have N equals the mass of the nitrogen gas divided by the molar mass of the nitrogen gas, this is going to be equal to 0.000226 kilograms, and then we'll divide this by, of course, 0.02814 kilograms per mole. And we are ending up with 8.067 times 10 to the negative third mole. And at this point, we have a temperature, we have a volume, and we have a number of moles. So now we can simply use the ideal gas law. So PV equals nRT, and P is going to be equal to nRT over V. And we simply need to plug in, so 8.067 times 10 to the negative third times 8.314, our ideal gas constant, and then times the temperature of 37.2 Kelvin, all divided by the gas of 0.00164. And at this point, we can say that P, we can just plug this into any calculator, P is going to be 1.52 times 10 to the third pascals. Atmospheric pressure is on the order of 10 to the fifth. So although this cylinder or this container, whatever it may be, is evacuated, it's still not approaching anywhere near a vacuum, really, because it's only 2 orders of magnitude away from the atmospheric pressure. But again, this would be the pressure associated with inside the system. And again, we just need to find the temperature from the root mean squared velocity and then we found a number of moles by dividing the mass divided by the molar mass. And then we can use the ideal gas constant, solve for P, plug in for our constants, and find the pressure. And that's the end of the solution. Thank you for watching.